The year was 1976. Deep within the Pentagon's most classified briefing rooms, a group of Navy admirals were about to present what they believed would be the future of American naval supremacy. But what they didn't know was that they were about to propose a weapon so powerful, so revolutionary, that it would terrify the very people who were supposed to approve it. Welcome to Never Built, where we explore the most ambitious technological failures in history. I'm your host, and today we're diving into the story of Project Strike Cruiser, the nuclear battleship that was too dangerous to exist. If you're fascinated by the engineering marvels that never made it off the drawing board, make sure to subscribe and let me know in the comments what lost technology you'd like us to investigate next. Picture this: a 17,000-ton nuclear-powered warship bristling with hundreds of Tomahawk cruise missiles, protected by the revolutionary Aegis defense system and armed with futuristic 203mm automatic cannons that could obliterate targets beyond the horizon. This wasn't just a ship, it was a floating fortress designed to operate alone in hostile waters, requiring no carrier protection, no escort vessels. It was meant to be the ultimate expression of American naval power. The concept emerged from the minds of naval strategists who had witnessed the changing face of warfare in the 1970s. The Soviet Union was rapidly expanding its submarine fleet, and traditional carrier battle groups were becoming increasingly vulnerable to new anti-ship missiles. The Navy needed something different, something that could project power without the massive logistical footprint of a carrier group. Admiral James Holloway, Chief of Naval Operations at the time, was the driving force behind this revolutionary concept. He envisioned a new class of warship that would combine the firepower of a battleship with the endurance of a nuclear submarine and the defensive capabilities of the most advanced air defense systems ever conceived. The strike cruiser, designated CSGN, was designed around three core principles: overwhelming firepower, nuclear endurance, and autonomous operation. Unlike traditional cruisers that served as escorts for aircraft carriers, the CSGN would be the centerpiece of its own battle group. Or better yet, it would operate entirely alone. The ship's nuclear propulsion system was based on the same reactor technology used in the Nimitz-class aircraft carriers, providing virtually unlimited range and endurance. This meant the strike cruiser could remain on station for months without refueling, patrolling vast ocean areas that would require multiple conventional ships to cover. But it was the weapon systems that truly set the CSGN apart from anything that had come before. The centerpiece of its armament was the Aegis Combat System, which was still in development at the time. This revolutionary radar and missile system could track and engage dozens of incoming threats simultaneously: aircraft, missiles, even small boats, with a level of precision that seemed almost magical to naval officers of the era. The strike cruiser would carry 128 vertical launch system cells, each capable of housing a variety of missiles: standard surface-to-air missiles for defense, Tomahawk cruise missiles for long-range strikes, and ASROC anti-submarine rockets. This gave the ship the ability to engage targets in the air, on the surface, underwater, and hundreds of miles inland. What do you think? Was this pure ambition or a dance with destiny? Let me know in the comments. The ship's gun armament was equally impressive. Two twin-mounted 203mm automatic cannons derived from the Army's experimental artillery systems could fire guided projectiles at targets up to 100 miles away. These weren't the manually operated guns of World War II battleships. They were fully automated systems capable of engaging multiple targets simultaneously while the ship maneuvered at high speed. The design called for a crew of just 400 sailors, compared to over 5,000 on a Nimitz-class carrier. Advanced automation and computer systems would handle many of the tasks that traditionally required large crews, making the strike cruiser not just more powerful than previous warships, but more efficient as well. The ship's hull design incorporated stealth technology that was cutting edge for the 1970s. Angular surfaces and radar-absorbing materials would reduce its radar signature, making it harder for enemy forces to detect and target. Combined with its speed of over 35 knots, the strike cruiser would be able to appear suddenly in a combat zone, deliver devastating firepower, and disappear before enemy forces could mount an effective response. Intelligence capabilities were built into every aspect of the design. The ship would carry advanced electronic warfare systems capable of intercepting enemy communications and jamming their radar and missile guidance systems. It would also serve as a command and control platform, coordinating the actions of other Navy units across vast ocean areas. The admirals who conceived the strike cruiser saw it as the answer to every challenge facing the Navy in the Cold War era. Soviet submarines, the CSGN's advanced sonar and anti-submarine weapons would hunt them down. Enemy surface ships, the Tomahawk missiles and naval guns would sink them from beyond visual range. Air attacks, the Aegis system would create an impenetrable defensive umbrella. But perhaps most importantly, the strike cruiser represented a fundamental shift in naval strategy. For decades, American naval doctrine had centered around the aircraft carrier as the primary instrument of power projection. The CSGN would change that, creating a new class of capital ship that could operate independently of carrier battle groups. This wasn't just about building a bigger, better warship. It was about reimagining what naval warfare could look like in the 21st century. The strike cruiser would be fast enough to outrun anything it couldn't outfight, powerful enough to destroy entire enemy fleets, and sophisticated enough to operate in the most complex electronic warfare environments. As the admirals prepared their presentation for Congress and the Pentagon's civilian leadership, they believed they were on the verge of ushering in a new era of American naval supremacy. They had no idea that their revolutionary warship would become one of the most controversial military programs in American history. The stage was set for a battle that would be fought not on the high seas, but in the corridors of power in Washington, D.C. And in that battle, the most advanced warship ever conceived would face its greatest enemy: politics. The conference room in the Pentagon was filled with the most powerful men in the American military establishment. It was March of 1977, and the Navy was about to make its case for the most expensive warship in history. But what they presented that day would shock even the most hawkish defense officials. Admiral James Holloway stood before a room full of skeptical faces, including Defense Secretary Harold Brown and Deputy Secretary Charles Duncan. The presentation materials were classified at the highest levels: detailed blueprints, cost projections, and strategic assessments that painted a picture of naval warfare unlike anything the world had ever seen. The strike cruiser program, officially designated CSGN for Cruiser Strike Guided Missile Nuclear, represented the Navy's answer to what they saw as a fundamental shift in the global balance of power. The Soviet Union had been rapidly expanding its naval capabilities throughout the 1970s, and American strategists were growing increasingly concerned about their ability to maintain control of the world's sea lanes. The numbers that Holloway presented were staggering. Each strike cruiser would cost approximately $1.2 billion in 1977 money, equivalent to nearly $6 billion today. The Navy wanted to build 8 of these ships, creating a fleet of nuclear-powered supercruisers that would patrol the world's oceans like modern-day battleships. But the cost was just the beginning of what made the CSGN program so controversial. The ship's nuclear propulsion system would require the same type of highly enriched uranium used in nuclear weapons, raising concerns about proliferation and security. Each ship would essentially be a floating nuclear reactor, capable of operating for 25 years without refueling. The technical specifications were unlike anything that had been proposed before. The ship would be 610 feet long and have a beam of 63 feet, making it larger than most World War II battleships. Its nuclear reactor would generate 100,000 shaft horsepower, enough to push the 17,000-ton vessel through the water at speeds exceeding 35 knots. The Aegis Combat System that would serve as the ship's primary defensive weapon was still in the early stages of development. The Navy was essentially asking Congress to fund a ship around a weapon system that didn't yet exist, based on the promise that it would revolutionize naval warfare when it was completed. Admiral Holloway explained that the Aegis system would use a powerful phased array radar to simultaneously track hundreds of incoming threats. The system could guide multiple interceptor missiles to their targets while continuing to search for new threats, creating a defensive umbrella that no previous warship could match. The strike cruiser's offensive capabilities were equally impressive. In addition to the 128 vertical launch cells for missiles, the ship would carry two Mark 71 8-inch gun systems. These weren't traditional naval guns. They were fully automated weapons capable of firing guided projectiles at targets up to 100 miles away. The ammunition for these guns was as revolutionary as the weapons themselves. Each shell would contain its own guidance system, allowing it to adjust its trajectory in flight to hit moving targets with pinpoint accuracy. The Navy envisioned these guns being used to support amphibious landings, destroy enemy ships, and even engage land-based targets far inland. What made the presentation even more compelling was the strategic context in which it was delivered. The Soviet Union had just launched the Kirov-class nuclear battlecruiser, a massive warship that represented a significant escalation in naval capabilities. American intelligence agencies were reporting that the Soviets were planning to build multiple Kirov-class ships, potentially giving them a significant advantage in any future naval conflict. The Navy argued that the strike cruiser was not just a response to the Soviet threat, but a way to leapfrog their capabilities entirely. While the Kirov was impressive, it was still based on conventional naval warfare concepts. The CSGN would represent a completely new approach to naval combat, one that would make existing warships obsolete. Admiral Holloway emphasized that the strike cruiser would be more than just a warship. It would be a symbol of American technological superiority. At a time when the United States was still reeling from the Vietnam War and facing economic challenges at home, the CSGN program would demonstrate that America could still produce the most advanced military technology in the world. The ship's crew requirements were another selling point. Traditional battleships required crews of over 2,000 sailors, while aircraft carriers needed more than 5,000. The strike cruiser, despite its size and complexity, would operate with just 400 crew members. Advanced automation and computer systems would handle many of the tasks that traditionally required large numbers of sailors. This reduction in crew size wasn't just about efficiency, it was about survivability. A smaller crew meant fewer people at risk in combat, and it also meant that the ship could continue operating even if it suffered significant casualties. The Navy projected that a strike cruiser could remain combat effective even if it lost up to 30% of its crew. The presentation included detailed wargaming scenarios that showed how strike cruisers would be employed in various conflict situations. In a confrontation with the Soviet Navy, a single CSGN could engage multiple enemy ships simultaneously while defending itself against air and submarine attacks. In a regional conflict, a strike cruiser could provide fire support for ground forces while also serving as a command and control platform for other Navy units. But perhaps the most compelling argument was the ship's ability to operate independently. Traditional Navy operations required large battle groups with multiple ships performing specialized roles: aircraft carriers for air power, destroyers for anti-submarine warfare, cruisers for air defense, and support ships for logistics. The strike cruiser could perform all of these roles with a single ship. This independence would give American naval commanders unprecedented flexibility. A strike cruiser could be deployed to a crisis area within days without the need to assemble a large battle group. It could remain on station for months without resupply, and it could engage any threat it encountered with overwhelming firepower. The Navy also argued that the strike cruiser would be more cost-effective in the long run than traditional battle groups. While the initial construction cost was high, the ship's nuclear propulsion system would eliminate fuel costs for its entire 25-year service life. The reduced crew size would also significantly lower operating costs compared to multiple conventional ships. As Admiral Holloway concluded his presentation, he painted a picture of a future where American naval power would be projected by a small number of highly capable ships rather than large fleets of specialized vessels. The strike cruiser would be the centerpiece of this new naval strategy, combining the best aspects of battleships, cruisers, and destroyers into a single, revolutionary platform. The room was silent as the implications of what they had just heard sank in. The Navy wasn't just asking for money to build new ships. They were proposing to fundamentally change the nature of naval warfare itself. And that change would come with a price tag that would make the CSGN program one of the most expensive military projects in American history. In the classified design laboratories of Newport News Shipbuilding, engineers were attempting something that had never been done before, creating a warship that could single-handedly dominate any ocean on Earth. But as they soon discovered, building the impossible would require innovations that pushed the boundaries of 1970s technology to their absolute limits. The chief naval architect for the strike cruiser project was Captain William Thompson, a brilliant engineer who had previously worked on the design of nuclear submarines. Thompson understood that the CSGN couldn't simply be a scaled-up version of existing ships. It would require entirely new approaches to naval architecture, weapons integration, and crew operations. The first challenge was the ship's hull design. Traditional warships were built with steel hulls that prioritized strength and durability over stealth characteristics. But the strike cruiser would need to be as invisible to enemy radar as possible while still maintaining the structural integrity to carry its massive weapons load. Thompson's team developed a revolutionary hull design that incorporated angular surfaces and radar-absorbing materials throughout the ship's structure. The superstructure was designed with sharp angles that would deflect radar waves away from their source, while special coatings would absorb electromagnetic energy across multiple frequency bands. The ship's nuclear propulsion system presented its own unique challenges. While the Navy had extensive experience with nuclear-powered submarines and aircraft carriers, the strike cruiser would require a reactor design that balanced power output with space efficiency. The ship needed to be fast and maneuverable, but it also had to carry an enormous weapons load. The solution was a new type of pressurized water reactor that generated 100,000 shaft horsepower while occupying less space than previous naval reactor designs. This reactor would be capable of propelling the ship at speeds exceeding 35 knots, while also providing electrical power for the ship's advanced electronics and weapon systems. The Aegis Combat System integration was perhaps the most complex engineering challenge of the entire project. The system's phased array radar required 4 large antenna arrays to be mounted on the ship's superstructure, each weighing several tons and requiring precise positioning to function properly. These radar arrays had to be integrated with the ship's stealth design without compromising either the radar's performance or the ship's reduced radar signature. Thompson's team developed an innovative mounting system that allowed the Aegis arrays to be partially recessed into the superstructure, while still maintaining their full scanning capabilities. The ship's weapon systems required equally innovative solutions. The 128 vertical launch system cells had to be arranged in a way that maximized firepower while maintaining the ship's stability and seaworthiness. Each cell was essentially a missile silo built into the ship's deck, capable of launching different types of missiles depending on the tactical situation. The Mark 71 8-inch guns presented their own engineering challenges. These weapons were based on Army artillery systems that had never been adapted for naval use. The guns had to be mounted in turrets that could traverse and elevate while the ship was moving through heavy seas, and they had to be integrated with the ship's fire control systems. Each gun turret was essentially a small fortress built into the ship's structure. The turrets were heavily armored to protect against enemy fire, and they contained their own ammunition handling systems that could automatically load and fire different types of projectiles without human intervention. The ammunition for these guns was as advanced as the weapons themselves. Each shell contained a miniaturized guidance system that could receive targeting updates from the ship's fire control computers. This, allowed the guns to engage moving targets at extreme ranges with accuracy that was impossible with conventional artillery. The ship's electronic warfare systems were integrated throughout the entire vessel. Rather than being concentrated in a single location, the electronic warfare equipment was distributed across multiple compartments to ensure that the ship could continue operating even if it suffered battle damage. These systems included powerful jammers that could disrupt enemy radar and communications, as well as sophisticated receivers that could intercept and analyze enemy electronic signals. The strike cruiser would be able to operate in the most complex electronic warfare environments while maintaining its own communications and sensor capabilities. The ship's command and control systems were designed around a revolutionary new concept called distributed computing. Instead of having a single combat information center, the strike cruiser would have multiple command stations throughout the ship, each capable of controlling different aspects of the ship's operations. This distributed approach meant that the ship could continue fighting even if its primary command center was destroyed. Backup command stations could take over control of weapon systems, navigation, and communications, ensuring that the ship remained combat effective under the most adverse conditions. The crew accommodations were designed with long-duration missions in mind. Unlike traditional warships that were designed for relatively short deployments, the strike cruiser would be capable of remaining at sea for months without resupply. This required innovative approaches to crew comfort and morale. Each crew member would have their own private sleeping compartment, a luxury that was unheard of on most Navy ships. The ship would also include recreational facilities, a library, and even a small gymnasium to help crew members maintain their physical and mental health during extended deployments. The ship's damage control systems were designed around the assumption that the strike cruiser would often be operating alone, without the support of other ships. This meant that the crew had to be capable of handling any emergency situation without outside assistance. Advanced fire suppression systems were built into every compartment of the ship, using a combination of water sprinklers, foam generators, and inert gas flooding systems. The ship's hull was divided into multiple watertight compartments, each with its own pumping systems to handle flooding from battle damage. The strike cruiser's logistics systems were designed to minimize the ship's dependence on shore-based support. The ship would carry enough food, spare parts, and ammunition to operate independently for up to 6 months. Advanced water purification systems would allow the crew to produce fresh water from seawater, while waste processing systems would minimize the ship's environmental impact. As the engineering challenges mounted, it became clear that the strike cruiser would be more than just an advanced warship. It would be a floating city capable of projecting American power anywhere in the world. But with each innovation came additional complexity and cost, pushing the program further into uncharted territory. What do you think about these engineering marvels? Were they pushing technology too far ahead of its time? Share your thoughts in the comments below. By late 1977, the engineering team had created detailed plans for what would have been the most advanced warship ever built. But as they would soon discover, engineering excellence alone wouldn't be enough to save the strike cruiser from the political battles that lay ahead. The year was 1978. And in a small office in the Congressional Budget Office, a young analyst named Patricia Morrison was staring at numbers that didn't make sense. The Navy's cost projections for the strike cruiser program seemed impossibly low for what they were proposing to build. What she discovered would ultimately doom the most ambitious warship project in American history. Morrison had been tasked with conducting an independent cost analysis of the CSGN program, and what she found was deeply troubling. The Navy's official estimate of $1.2 billion per ship was based on optimistic assumptions about construction costs, technology development, and program management that had no basis in historical reality. Her analysis showed that the true cost of each strike cruiser would likely exceed $2 billion in 1978 money, nearly $10 billion in today's currency. For the Navy's planned fleet of 8 ships, the total program cost would approach $20 billion, making it one of the most expensive military programs in American history. The cost overruns weren't just a matter of inflation or miscalculation. They were built into the very nature of what the Navy was trying to accomplish. The strike cruiser program was attempting to develop multiple revolutionary technologies simultaneously, each of which carried enormous technical and financial risks. The Aegis Combat System alone was projected to cost over $300 million per ship, and that was assuming the technology could be successfully developed and integrated. At the time, Aegis existed only as a series of prototypes and computer simulations. No one knew for certain whether it would actually work as advertised. The ship's nuclear propulsion system presented similar challenges. While the Navy had experience with nuclear-powered ships, the strike cruiser's reactor would be a completely new design optimized for high speed and maneuverability. Developing and testing this reactor would require years of research and hundreds of millions of dollars in development costs. The Mark 71 gun systems were equally problematic from a cost perspective. These weapons were based on Army artillery systems that had never been adapted for naval use, and the integration challenges were proving far more complex than originally anticipated. Each gun turret was essentially a custom-built piece of equipment that would require extensive testing and refinement. Morrison's analysis also revealed significant concerns about the program's management structure. The strike cruiser project involved multiple contractors working on different aspects of the ship's design, with limited coordination between them. This fragmented approach virtually guaranteed cost overruns and schedule delays. The shipbuilding industry itself was facing significant challenges in the late 1970s. Newport News Shipbuilding, the Navy's preferred contractor for the strike cruiser, was already struggling with cost overruns on other nuclear ship programs. Adding the complexity of the CSGN project to their workload would likely exacerbate these problems. Labor costs were another major concern. Building a strike cruiser would require highly skilled workers with experience in nuclear technology, advanced electronics, and precision manufacturing. These workers commanded premium wages, and there was a limited supply of people with the necessary qualifications. The program's schedule was equally problematic. The Navy wanted the first strike cruiser to be operational by 1985, but Morrison's analysis suggested that this timeline was completely unrealistic. Developing the ship's advanced technologies would take years longer than the Navy projected, pushing the first delivery well into the 1990s. These delays would have a cascading effect on costs. Inflation would increase the price of materials and labor, while extended development timelines would require additional funding for research and testing. The longer the program took to complete, the more expensive it would become. Morrison also identified significant risks associated with the program's international implications. The strike cruiser's advanced technologies could potentially be shared with allied nations, but export controls and security concerns would limit the Navy's ability to recoup development costs through foreign sales. The opportunity costs of the strike cruiser program were staggering. The money required to build 8 nuclear supercruisers could instead be used to build dozens of conventional ships, modernize existing vessels, or invest in other military technologies that might provide greater strategic value. Congressional budget analysts began comparing the strike cruiser to other major military programs of the era, and the comparisons were not favorable. The B-1 bomber program, which was facing its own cost overruns and technical challenges, seemed modest by comparison to what the Navy was proposing. The political implications of Morrison's analysis were immediately apparent to congressional leadership. Supporting the strike cruiser program would require massive increases in defense spending at a time when the country was facing economic challenges and growing public skepticism about military expenditures. Defense Secretary Harold Brown was briefed on the cost analysis findings in early 1979, and his reaction was swift and decisive. He ordered a comprehensive review of the entire CSGN program, including its strategic justification, technical feasibility, and cost projections. The Navy's response to these cost concerns was to argue that the strike cruiser's capabilities justified its expense. Admiral Holloway pointed out that a single CSGN could perform missions that would otherwise require multiple conventional ships, making it cost-effective despite its high unit price. But this argument failed to convince budget analysts and congressional leaders who were looking at the program's total cost rather than its theoretical efficiency. The idea of spending $20 billion on 8 ships seemed excessive regardless of their capabilities. The cost analysis also revealed that the Navy had not adequately considered the long-term implications of operating nuclear-powered cruisers. These ships would require specialized maintenance facilities, highly trained crews, and secure storage for nuclear fuel and waste. These infrastructure costs would add billions more to the program's total price tag. As word of the cost overruns leaked to the press, public opinion began to turn against the strike cruiser program. Newspaper editorials questioned whether the country could afford such an expensive weapon system, especially when there were pressing domestic needs that required government funding. The timing couldn't have been worse for the Navy. The country was entering a period of economic uncertainty, with rising inflation and growing concerns about government spending. The idea of building billion-dollar warships seemed increasingly out of touch with the nation's priorities. By the end of 1979, it was becoming clear that the strike cruiser program was in serious trouble. The cost analysis had revealed fundamental problems with the Navy's planning and budgeting, and congressional support for the program was rapidly eroding. The billion-dollar question had become a $20 billion problem, and the Navy was running out of time to find a solution. The most advanced warship ever conceived was about to become a casualty of its own ambition and the harsh realities of government budgeting. The hearing room in the Russell Senate Office building was packed with reporters, defense contractors, and military officials. It was April of 1979, and Senator Sam Nunn, chairman of the Armed Services Committee, was about to grill Navy leadership about the most controversial weapons program in decades. What happened next would determine the fate of the strike cruiser and reshape American naval strategy for generations. Admiral James Holloway sat at the witness table, surrounded by thick binders of classified documents and technical specifications. Across from him, Senator Nunn shuffled through his own stack of papers, cost analyses, intelligence reports, and Congressional Budget Office projections that painted a very different picture of the CSGN program than what the Navy had been presenting. The political battle over the strike cruiser had been building for months. Word of the massive cost overruns had leaked to the press, and congressional leaders from both parties were demanding answers. The program had become a symbol of everything that was wrong with defense procurement: massive cost overruns, unrealistic timelines, and technologies that existed more in theory than in practice. Senator Nunn opened the hearing with a devastating question. Admiral Holloway, can you explain to the American people why they should spend $20 billion on 8 ships when that same money could build 40 conventional cruisers or fund the entire food stamp program for 2 years? Holloway's response revealed the fundamental disconnect between military and civilian leadership. He argued that the strike cruiser represented a revolutionary leap in naval capabilities that couldn't be measured in simple cost comparisons. One CSGN could accomplish missions that would require an entire battle group of conventional ships. But Senator William Proxmire of Wisconsin, known for his opposition to government waste, wasn't buying it. He pointed out that the Navy's own war games showed that conventional ships could accomplish the same missions at a fraction of the cost. The strike cruiser's advantages, while real, didn't justify its astronomical price tag. The hearing revealed deep divisions within the defense establishment itself. While Navy leadership strongly supported the CSGN program, other service branches were less enthusiastic. Air Force generals questioned whether naval surface ships would be relevant in future conflicts, while Army leaders argued that the money would be better spent on land-based systems. Defense Secretary Harold Brown found himself caught in the middle of this bureaucratic warfare. He had initially supported the strike cruiser concept, but the cost analyses and congressional pressure were forcing him to reconsider. Brown was a physicist by training, and he understood the technical challenges better than most politicians. The Carter administration was facing multiple challenges in 1979. The Iranian hostage crisis was dominating headlines, inflation was rising, and the president's approval ratings were falling. The last thing the administration needed was a controversial weapons program that symbolized government excess and mismanagement. President Carter himself was deeply skeptical of large military programs. A former Navy officer, he understood naval operations better than most presidents, but he was also committed to reducing defense spending and focusing on domestic priorities. The strike cruiser represented everything he opposed about the military-industrial complex. The political dynamics were complicated by the fact that the CSGN program had strong support in certain congressional districts. Newport News Shipbuilding was located in Virginia, represented by powerful senators who saw the program as essential to their state's economy. Canceling the strike cruiser would mean eliminating thousands of high-paying jobs in a politically important region. Defense contractors were lobbying heavily for the program, arguing that canceling it would damage America's technological edge and hurt the defense industrial base. Companies like General Dynamics, Lockheed, and Raytheon had invested millions of dollars in developing technologies for the strike cruiser, and they wanted to see a return on that investment. The intelligence community was divided on the program's strategic value. Some analysts argued that the Soviet Union's naval expansion required a strong American response, and the strike cruiser was the most effective way to maintain naval superiority. Others contended that the threat was overstated and that conventional ships would be adequate for any likely conflict. International allies were also weighing in on the debate. NATO partners were concerned that the strike cruiser's high cost would divert resources from other defense priorities that were more relevant to European security. Some allies also worried that the ship's advanced technologies might not be shared with them, reducing interoperability in joint operations. The press coverage of the strike cruiser program was overwhelmingly negative. Newspaper editorials criticized the program as an example of Pentagon excess, while investigative reporters uncovered additional cost overruns and technical problems that the Navy had tried to keep secret. Television news programs began featuring the strike cruiser as a symbol of government waste, often contrasting its billion-dollar cost with pressing domestic needs like education, healthcare, and infrastructure. The visual of a massive warship became a powerful metaphor for misplaced priorities. Public opinion polls showed that a majority of Americans opposed the strike cruiser program once they learned about its cost. The idea of spending billions on a single ship seemed absurd to voters who were struggling with inflation and economic uncertainty. The Navy tried to counter this negative publicity by emphasizing the program's technological innovations and strategic importance. They arranged briefings for journalists and congressional staff, hoping to build support for the CSGN by explaining its capabilities in detail. But these efforts largely backfired. The more the Navy explained about the strike cruiser's advanced technologies, the more questions arose about whether these innovations were actually necessary or achievable. The program began to seem like science fiction rather than serious military planning. Admiral Holloway found himself increasingly isolated as opposition to the program mounted. Even within the Navy, some officers began to question whether the strike cruiser was worth the political capital it was consuming. The program was becoming a distraction from other naval priorities that had broader support. The final blow came when the Congressional Budget Office released its comprehensive analysis of the program in late 1979. The report concluded that the strike cruiser would cost far more than projected, take much longer to develop than promised, and provide capabilities that weren't essential to national security. What's your take on this political battle? Do you think the politicians were right to kill the program, or should they have trusted the military's judgment? Let me know your thoughts in the comments. By the end of 1979, it was clear that the strike cruiser had lost the political battle. The combination of cost overruns, technical uncertainties, and changing strategic priorities had created an insurmountable coalition of opposition. The most advanced warship ever conceived was about to become a victim of the democratic process. It was a cold morning in January of 1980 when Defense Secretary Harold Brown walked into the Pentagon briefing room to deliver what would become known as the death sentence for the strike cruiser program. The assembled Navy leadership knew what was coming, but the finality of Brown's words still hit them like a physical blow. 20 years of planning, billions in development costs, and the dreams of an entire generation of naval officers were about to be swept away with a single decision. Brown's announcement was brief and to the point. After extensive review and analysis, the Department of Defense has decided to terminate the strike cruiser program effective immediately. The fiscal realities and strategic priorities of the 1980s require us to pursue more cost-effective alternatives for naval modernization. The room fell silent as the implications sank in. Admiral Holloway, who had championed the program from its inception, sat stone-faced as his life's work was officially declared dead. Around him, other naval officers struggled to process the end of what they had believed would be the future of American naval power. The decision had been months in the making, driven by a perfect storm of political, economic, and strategic factors that made the strike cruiser program impossible to sustain. The Carter administration's commitment to reducing defense spending, combined with congressional opposition and mounting cost overruns, had created an environment where even the most advanced military technology couldn't survive. The immediate aftermath of the cancellation was chaotic. Newport News Shipbuilding, which had been preparing to build the first strike cruiser, suddenly found itself with thousands of workers assigned to a project that no longer existed. The company's stock price plummeted as investors realized that one of its most lucrative contracts had vanished overnight. Defense contractors across the country scrambled to salvage what they could from their strike cruiser investments. Companies like Raytheon, which had been developing the Aegis Combat System specifically for the CSGN, suddenly had advanced technologies with no platform to carry them. The question became, what do you do with revolutionary weapon systems when the ship they were designed for no longer exists? The answer would reshape the entire trajectory of American naval development. Rather than abandoning the technologies developed for the strike cruiser, the Navy decided to adapt them for use on smaller, more affordable ships. The Aegis system, which had been the centerpiece of the CSGN's capabilities, would be installed on a new class of conventional cruisers based on the existing Spruance-class destroyer hull. This decision led to the creation of the Ticonderoga-class cruisers, which would become the backbone of American naval air defense for the next 4 decades. While these ships lacked the strike cruiser's nuclear propulsion and massive firepower, they retained its most important capability: the ability to defend against multiple air and missile threats simultaneously. The Mark 71 gun systems developed for the strike cruiser faced a different fate. Without a platform large enough to carry them, these revolutionary weapons were abandoned entirely. The Navy returned to conventional 5-inch guns for its surface ships, giving up the long-range precision strike capabilities that the 8-inch guns would have provided. The cancellation of the strike cruiser also marked the end of American experiments with nuclear-powered surface combatants. The Navy's experience with nuclear cruisers had been mixed at best, with high operating costs and complex maintenance requirements offsetting the advantages of unlimited range and endurance. Admiral Holloway retired from the Navy shortly after the program's cancellation, a broken man who had seen his vision of future naval warfare destroyed by political and economic realities. In his farewell address, he warned that the United States was making a strategic mistake that would limit its naval capabilities for decades to come. The human cost of the strike cruiser's cancellation extended far beyond the Navy's leadership. Thousands of engineers, technicians, and shipyard workers who had dedicated years of their lives to the program suddenly found themselves without work. Many left the defense industry entirely, taking their expertise with them and weakening America's naval industrial base. The international implications of the cancellation were equally significant. Allied nations that had been counting on American naval leadership in developing next-generation warships were forced to pursue their own programs or settle for less capable alternatives. The cancellation sent a message that the United States was retreating from its commitment to maintaining naval superiority. Soviet naval planners, meanwhile, were jubilant about the strike cruiser's demise. Intelligence reports from the time show that they had been deeply concerned about the CSGN's capabilities and had been developing countermeasures specifically designed to deal with nuclear-powered American supercruisers. The program's cancellation removed a major threat to Soviet naval operations. The technical knowledge gained from the strike cruiser program wasn't entirely lost. Many of the innovations developed for the CSGN found their way into other naval systems over the following decades. Advanced radar technologies, improved nuclear reactor designs, and sophisticated weapons integration concepts all benefited from the research conducted for the strike cruiser. However, the loss of institutional knowledge was significant. The teams of engineers and naval architects who had worked on the program dispersed to other projects or left the industry entirely. The unique combination of expertise that had made the strike cruiser possible was never reassembled. The program's cancellation also had lasting effects on Navy culture and strategic thinking. The failure of such an ambitious project made naval leadership more conservative in their approach to future programs. The willingness to pursue revolutionary technologies and radical new concepts was replaced by a preference for incremental improvements to existing systems. This conservative approach would characterize American naval development for the next 2 decades. While it reduced the risk of costly failures like the strike cruiser, it also limited the Navy's ability to make breakthrough advances in naval technology. The service that had once been willing to bet everything on revolutionary new concepts became risk-averse and bureaucratic. The strike cruiser's legacy lived on in the debates about military procurement and strategic planning that continue to this day. The program became a case study in how not to manage complex defense projects, with its cost overruns and unrealistic timelines serving as cautionary tales for future generations of defense officials. But the program also represented something more positive: the willingness to dream big and pursue revolutionary advances in military technology. While the strike cruiser ultimately failed, the ambition and vision that drove its development reflected the best aspects of American innovation and engineering excellence. As the 1980s began, the American Navy found itself at a crossroads. The failure of the strike cruiser program had forced a fundamental reevaluation of naval strategy and priorities. The service would have to find new ways to maintain its technological edge and strategic relevance in an increasingly complex and dangerous world. The death of the strike cruiser dream marked the end of an era in American naval history. Never again would the Navy attempt such an ambitious and revolutionary program. The age of incremental improvement had begun, and with it, a more cautious and conservative approach to naval innovation that would define American sea power for generations to come. 30 years after the strike cruiser's cancellation, Admiral Michael Mullins stood on the bridge of the USS Zumwalt, the Navy's newest and most advanced destroyer. As he watched the ship's automated systems track multiple targets simultaneously, he couldn't help but wonder, what would the world look like today if the CSGN program had succeeded? The question haunted not just naval historians, but anyone who understood the profound impact that revolutionary technologies can have on the course of history. The alternate timeline where strike cruisers patrolled the world's oceans is fascinating to contemplate. By the mid-1980s, the first CSGN would have been operational, fundamentally changing the balance of naval power. The Soviet Union's naval expansion, which posed such a significant threat in our timeline, might have been completely neutralized by the presence of nuclear-powered American supercruisers. The Falklands War of 1982 provides an interesting case study. In our timeline, the British Royal Navy struggled to maintain air defense coverage for their task force, losing several ships to Argentine air attacks. A single strike cruiser, with its Aegis system and long-range missiles, could have provided complete air defense coverage for the entire British fleet, potentially preventing any losses to air attack. The Iran-Iraq War, which raged throughout the 1980s, saw numerous attacks on merchant shipping in the Persian Gulf. The United States was forced to deploy large naval forces to protect Kuwaiti tankers during Operation Earnest Will. A single strike cruiser could have accomplished this mission alone, providing both air defense and surface strike capabilities without requiring the massive logistical support of a carrier battle group. The technological implications of a successful CSGN program would have been enormous. The advanced automation systems developed for the strike cruiser would have accelerated the development of artificial intelligence and robotics by decades. The ship's distributed computing architecture was 20 years ahead of its time and could have revolutionized not just naval systems, but civilian technology as well. The Aegis Combat System, which was eventually deployed on Ticonderoga-class cruisers, would have been far more advanced if it had been developed for the strike cruiser's larger platform. The additional space and power available on the CSGN would have allowed for more powerful radars, longer-range missiles, and more sophisticated electronic warfare capabilities. The Mark 71 gun systems, which were abandoned when the strike cruiser was canceled, represented a revolution in naval gunfire that never occurred. These weapons could have provided precision strike capabilities that wouldn't be matched until the development of GPS-guided munitions decades later. The ability to engage land targets at ranges exceeding 100 miles would have given the Navy unprecedented power projection capabilities. The strategic implications of strike cruiser deployment would have been profound. The ship's ability to operate independently would have allowed the United States to maintain a naval presence in multiple regions simultaneously without the massive logistical requirements of carrier battle groups. This could have fundamentally altered the geopolitical balance of the Cold War. Soviet naval strategy was built around the assumption that American carrier battle groups were vulnerable to coordinated attacks by submarines, aircraft, and surface ships. The strike cruiser would have been far more difficult to counter, as it combined the defensive capabilities of an entire battle group with the mobility and stealth of a single ship. The economic implications of the CSGN program's success would have been significant as well. The advanced technologies developed for the strike cruiser would have had numerous civilian applications, potentially accelerating American technological development and economic growth. The program could have been a catalyst for innovation similar to the Apollo space program. The shipbuilding industry would have been transformed by the strike cruiser program. The advanced manufacturing techniques required to build these ships would have kept American shipyards at the forefront of global technology, potentially preventing the decline of the domestic shipbuilding industry that occurred in the following decades. From a military perspective, the strike cruiser would have changed the entire structure of the Navy. The traditional emphasis on aircraft carriers as the centerpiece of naval power would have been challenged by ships that could operate independently and accomplish many of the same missions at lower cost and with greater flexibility. The crew training and retention implications would have been significant as well. The strike cruiser's advanced automation would have required highly skilled technicians and operators, potentially raising the overall technical competence of the entire Navy. The ship's comfortable living conditions and prestigious status would have made it easier to recruit and retain top-quality personnel. International relations would have been affected as well. Allied nations would have been eager to purchase strike cruiser technology or participate in joint programs, strengthening military and political ties. The ship's capabilities would have made it an attractive platform for coalition operations, enhancing American leadership in international security affairs. The environmental implications of nuclear-powered surface ships operating globally would have been controversial, but potentially positive. The strike cruiser's nuclear propulsion would have eliminated the massive fuel consumption of conventional warships, reducing the Navy's carbon footprint and dependence on fossil fuels decades before climate change became a major concern. The development of stealth technology for the strike cruiser would have accelerated advances in radar-absorbing materials and signature reduction techniques. These innovations could have been applied to aircraft, submarines, and ground vehicles, giving American forces a significant advantage in electronic warfare and survivability. The program's impact on defense procurement practices could have been transformative as well. If managed successfully, The strike cruiser could have served as a model for how to develop revolutionary military technologies without the cost overruns and delays that plagued so many other programs. Looking at today's naval challenges, many of the capabilities that the strike cruiser would have provided are still needed. The rise of China as a naval power, the proliferation of advanced anti-ship missiles, and the increasing importance of missile defense all point to the continuing relevance of the CSGN concept. Modern naval planners are once again considering large, heavily armed surface combatants as a way to counter emerging threats. The Navy's current plans for next-generation destroyers and cruisers bear striking similarities to the strike cruiser concept, suggesting that the basic idea was sound, even if the execution was flawed. The lessons learned from the strike cruiser's failure have influenced every major defense program since. The importance of realistic cost estimates, achievable technical goals, and sustained political support are now well understood, even if they're not always successfully implemented. What do you think? Could the strike cruiser have changed the course of naval history, or was it destined to fail regardless of political support? I'd love to hear your thoughts on this fascinating what-if scenario in the comments below. Perhaps the most important legacy of the strike cruiser program is the reminder that technological progress requires both vision and pragmatism. The engineers and naval officers who conceived the CSGN had the vision to imagine a revolutionary new type of warship, but they lacked the pragmatic understanding of political and economic realities necessary to make their dream a reality. As we face new challenges in the 21st century, the strike cruiser's story serves as both inspiration and warning. It reminds us that breakthrough technologies are possible, but only if we're willing to balance ambition with realism, innovation with affordability, and military requirements with political feasibility. The strike cruiser may never have sailed the world's oceans, but its legacy lives on in every advanced warship that followed. The technologies developed for the CSGN, the lessons learned from its failure, and the vision of, and perhaps, in some alternate timeline, strike cruisers still patrol the world's oceans, silent guardians of a future that never came to pass.